Okay, what we're going to do here, we're going to try and break down the blink without delay sketch into a simple form, as easy as possible, because when you start off this can be very hard to get your head around. The first thing I'm going to show you is a timeline. Each Arduino has an inbuilt clock, and it will start as soon as you plug in the Arduino or reset it, and it will just run continuously. I'm going to keep it very simple. I'm going to just divide it into a couple of seconds. So here's 0, 0 0.5, 1, 1.5, 2, 2.5. After that, we're going to look at the code. Now I'm going to take shorthand on the code and I'm going to slim it down. So this isn't the actual code, it's just some shorthand. Okay, one of the things we're going to have in the code is the previous. And that originally will be 0. And there will be a state for your LED, and we're going to have the state low to start with. Then we're going to look at our loop. Okay, in the loop, the first thing we're going to do is we're going to read the time. Okay, and then after that, what we're going to do is we're going to look at an if statement. So if the time, which we've just read, minus the previous equals, what we're going to do is, it's greater than or equal to, we're going to do a delay of 500, or replace a delay of 500. So we're going to look at the time. So the time is read, so as we move along, it reads the time. So this is the very first time it runs, so it's going to be about here, which is about 1 millisecond. So the time at the moment is going to be 1 millisecond. So that's 1. And previous we know is 0. So if we get time, which is 1, take away 0 is 1. Is that greater or less than 500? No. So it's going to skip that section and it's going to go on down to the bottom. At the bottom, we're just going to have a simple digital write. And we're going to do the state, whatever state it is. In this case, it's low. So your LED isn't going to light. It's going to be off. It's going to keep running this code, loop, 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 millions of times, all the way along. Until it gets to, we'll take this part here. We're now at 500 milliseconds. So we come along here, it's still previous, it's still off. We read the time. It is now 500 milliseconds past. So here it is, if the time, which is 500 at the moment, take away the previous, which is still 0, is greater than or less than, or greater than or equal to 500, then we do what's in this statement. So we're actually going to go in here now. In here we'll put another if statement, and we're going to basically change the light from on to off. So we're going to look at the light, and if it's low, what we want to do is change it to high. State high. If it's not low, so else, it's obviously high. In that case, we want to change it to low. So that will swap the state. So if we come in here and it's true, we come in here and it's low, which it is, it will change the state to high. So this will now turn the light on, or the LED on. And we also reset the previous. So that previous equals time. So the previous is now the current time, which is 500. So our previous is now 500. And then it goes underneath here and digital writes the state, which in this time is high, turning on the LED. Again, this starts running loads and loads and loads of times. We're going to take here, for example. And right here is 750 milliseconds. So the time, the previous is still right, the state is still high. We'll come in here, read the time. It is now 750 milliseconds. We come down here, so if the time, which is 750, subtract the previous, which is now 500. So that, take away that, is 250. Is that greater than or equal to 500? No. So it skips it, writes the state, which is still high, still keeping it on. We'll keep moving along our timeline till we reach 1 second. So now, oh sorry, it still says 500. Now our real time is actually 1 second, so 1000 milliseconds. If the time, which is 1000 milliseconds now, subtract the previous, which was 500, so that will give us an answer again of 500, is greater than or equal to 500, which it is, move in here. Now if it's low, this isn't low, it's high at the moment, so it'll skip that, else it'll go here, state changed to low. So this will change to low. So now we have the LED switched off. And then it resets the previous time. So to reset the time to 1000, because it's setting the previous time to be equal to the current time. And the loop starts again, going over and over and over again. And it keeps doing this loop over and over again, changing every second, every half second. And what we're going to do is we're going to pop over to the code now, the actual code. We'll run through that and explain that. Okay. First thing we're going to do, we're going to make this little project here. It's 2 LEDs, one red, one blue. Red flashes every 200 milliseconds, blue every second, so every 1000 milliseconds. This is our code. We're going to go to the top. First thing we're going to do is initiate both of our LEDs and their pins. So red is on pin 0 and blue is on pin 1, and they're both going to have a state of low. That's their state, they're both off at the start. Next we're going to do is we're going to give it a previous. So if you remember from our sketch here, let me focus. So our previous was the time that was reset every time it went through the if loop. So the previous was here, so we subtracted the time from the previous. We're going to set our previous to 0 initially for both of them. And what unsigned long means is a long means it's a long number. So this could get into the, it's milliseconds and it could be running for days. So it's going to be a huge number, and unsigned means it's going to stay as a positive, no negatives. Constant long is again just their interval. So it's a long number, it's going to be 200. In this case you could use an integer, it's not going to make a difference. For our red, their intervals are going to be 200 milliseconds and our blue is going to be 1000 milliseconds. So on and off times for those. Our setups, they're both outputs. We go to our loop. The first thing we're doing, if you remember from our sketch, is the first thing we do is we read the time. So if we take a look here, unassigned long, again it's going to be a positive and it's going to be a huge number after a while. Current mil, so the current time, we're going to name it, and it's going to read the time. So for example, if it's 10 milliseconds, we're going to take 10 milliseconds, it'll come down here, 10 milliseconds, subtract the previous, which is 0, which makes 10. Is that greater than or equal to 200? In this case, it's obviously not, so it skips. Down to this one, and it's going to be the same for blue, 10 take away 0. Is that greater than or equal to 1000? No. So it comes down here and it'll write the states. It'll write red as low and B as low, because that's what they're set at originally, low and low. Let's come here, and for example it will run through all the time, going up through all the milliseconds till it reaches 200. So we're going to imagine this at 200 now. Unsigned long, current mils 200. If the current mils, which is 200, subtract 0, is greater than or equal to 200, we do what's in here, and it is, so it comes in here. First thing we're going to do is we're going to rewrite the previous red to current mills at the moment, which is 200. So now previous is 200. And then it's going to go if the state of red is low, which it is, change it to high. Otherwise, leave it low or change it to low. So that's going to turn on our red LED. It's going to skip again. It's going to skip the blue because it's not at 1000 yet. So here it will change. So at the bottom it'll write the red LED as high, but it will keep the blue LED as low. And it will keep running through again and again until it gets to such a time that it changes the blue to a high, at which point the red LED will have changed quite a number of times because it will have passed the 200 mark 5 times. So that's the code. I hope this video has helped clear up this mess that is working with delays. It's difficult to get your head around at first, but once you start using this instead of a delay, you'll find it much easier if you want to include any buttons in your projects, because you won't have to worry about delays and buttons not working during delays. So it's worthwhile taking the time, trying a few of them, and if you want to find the example, just in case you didn't know where it is, if you open up your Arduino, go to examples, there it is, digital blink without delay. And this is the example I worked from. It's not the same as mine, but it's pretty similar. Thanks for watching.